Appearance of deep-sea fish does not signal upcoming earthquake in Japan. The unusual appearance of deep-sea fish like the oarfish or slender ribbonfish in Japanese shallow waters does not mean that an earthquake is about to occur, according to a new statistical analysis. The study published in the Bulletin of the Seismological Society of America contradicts long-held Japanese folklore that deep-sea fish sightings are a sign of an imminent earthquake, say Yoshiaki Orihara of Tokai University in Japan and colleagues. When the researchers examined the relationship between deep-sea fish appearances and earthquakes in Japan, however, they found only one event that could have been plausibly correlated, out of 336 fish sightings and 221 earthquakes. As a result, one can hardly confirm the association between the two phenomena, the authors write in the BSSA paper. The study included data from November 1928 to March 2011, looking at records of deep-sea fish appearances 10 and 30 days ahead of earthquakes that occurred 50 and 100 kilometers away from the fish sighting. They confined their search to earthquakes of magnitude 6.0 or larger, since these are the earthquakes that have been linked to precursor phenomena like unusual animal behavior in previous reports, said Orihara. There were no recorded deep-sea fish appearances before an earthquake of magnitude 7.0, and no earthquakes with a magnitude greater than 6.0 occurred within 10 days of a deep-sea fish appearance. Orihara became interested in the deep-sea fish stories after the 2011 magnitude 9.0 Tohoku earthquake in Japan. If the stories were true, he said, deep-sea fish appearances could be used in disaster mitigation efforts. From this motivation, we started compiling the event catalog for statistical study, said Orihara. There were some previous papers to survey deep-sea fish appearances. However, their reports were insufficient for a statistical study. To collect a lot of events, we focused on local newspapers that have often reported the events. The researchers scoured a digitized database of newspaper articles to find mentions of the unusual appearance of deep-sea fish that folklore says will appear before an earthquake, including oarfish, several kinds of ribbonfish, dealfish and the unicorn crestfish. Orihara said that he and his colleagues expect that their results will have an influence on people who believe the folklore, and they hope that their findings will be shared throughout Japan. Satellite observations improve earthquake monitoring. Response researchers at the University of Iowa and the U.S. Geological Survey have found that data gathered from orbiting satellites can provide more accurate information on the impact of large earthquakes, which, in turn, can help provide more effective emergency response. The satellite imagery provides detailed information about where the earthquakes occurred, how big the surface deformation was, and where the earthquakes occurred relative to population centers, typically within 2 to 3 days of the earthquake. This information was then incorporated into a set of operational response guides managed by the USGS National Earthquake Information Center (NEIC) that is distributed to decision makers, search and rescue operations, and other groups. In the paper published online June 6 in the journal Remote Sensing, the researchers determined that the satellite imagery gathered from each earthquake provided new information, which improved the analysis of its impact. This, in turn, led to more accurate estimates of the numbers of fatalities and economic losses that are critical to more accurately determine in the days and weeks following devastating earthquakes, says Bill Barnhart, assistant professor in the Department of Earth and Environmental Sciences at the UI and a lead author on the study. Mainstays in determining an earthquake's impact are ground-based seismometers that measure seismic activity around the world. But these instruments are not located everywhere, which can lead to incomplete information about the effects of some earthquakes in the critical time immediately after they occur. Moreover, some quakes are more complex and can't be measured precisely by seismometers alone. Increasingly, earthquake specialists are turning to geodetic methods, the math-based study of changes in the Earth's shape, that use satellites and other instruments to complement data gathered by seismometers. While this is not yet a fully operational system, we are working with the USGS to make operational earthquake response with satellite imagery a systematic component of the NEIC's global earthquake monitoring and response efforts, Barnhart says. One example is the work done by Emma Mankin, a UI senior and geoscience major who will graduate in December. Mankin processed radar imagery, or interferograms, from a 6.9 magnitude quake that struck Indonesia in August 2018. She then used this imagery to produce a model of the earthquake and where it was located. The USGS used this model directly to update its predictions of ground shaking and earthquake impact that were incorporated into its disaster response systems. EMA's rapid work on the Indonesia earthquake directly contributed to the operational analysis of a global earthquake, Barnhart says. Her contributions improved earthquake impact estimates for that event and helped to further demonstrate that these satellite approaches can provide actionable information that benefits society. Contributing authors include Gavin Hayes and David Wald from the USGS National Earthquake Information Center. The USGS funded the research.